Go.
Fellow soil scientists, it's my great privilege and honor to talk to you regarding my viewpoints for the month of July 2018. The subject that I've chosen for this month's viewpoint is drylands. The UN declared 2010 to 2020 as the decade for deserts and the fight against desertification. World's drylands represent 41.3% or 60.9 million square kilometers of Earth's land area and comprise of desert 6.6%, semi-desert 10.6%, grasslands 15.2%, and rangeland 8.7%. Drylands are home to about 2.7 billion people during 2018 and represent 35.5% of the world's population. Drylands, being strongly impacted by desertification, have already expanded by 4 to 8% over the 20th century and may continue to expand by an additional 10% compared with the baseline of 1961-1990 and probably cover as much as 50% of Earth's land area by 2100. Drylands contain 46% of global carbon stocks, comprising of 53% of the global soil carbon stock and 14% of the global biotic carbon stock. Among 10 known centers of the origin of agriculture, around circa 10,000 BC, domestication of plants and animals began mostly in world's dryland, such as the Fertile Crescent, the Indus Valley, Southwest Asia, Southeast Asia, and Central America. These ecoregions, characterized by long drought events, supported plants with large annual seeds, such as wheat, einkorn, barley, peas, lentils, chickpeas, flax, and others. And these seeds survived during the long period and germinated whenever it rained. Present day, about 50% of world's productive land is dryland, and 50% of world's livestock is in drylands. With the increase in population and change in climate, however, drylands are increasingly prone to desertification. The projected climate change would lead to increasingly drier, deep soil layers during the growing season and adversely impact the provisioning of critical ecosystem services, including water, biodiversity, food, and feed. The reduction in soil moisture storage would aggravate warming, increase evapotranspiration, exacerbate depletion of soil water reserve, and severely reduce the grain yield of cereals. On the contrary, restoration of degraded and desertified drylands and ecosystems can sequester carbon both in biomass and soil, contribute towards mitigating anthropogenic climate change, enhance socio-ecological resilience, and improve the environment. The carbon sequestration potential of soils of drylands has been estimated at 0.7 to 1.3 gigaton of carbon per year, and this potential is equivalent to 10% of the global fossil fuel emission on an annual basis. However, the available soil moisture content in the root zone, or the so-called green water, is the most critical factor to restoring degraded drylands and strengthening ecosystem services, especially the net primary productivity. Similarly, the dryland farming based on conservation and judicious management of rainwater in the root zone is essential to improving and sustaining productivity in these harsh environments. Restoration of soil health in dryland is also essential to advancing the Sustainable Development Goals of the UN, or the so-called Agenda 2030, especially goal number 2, end hunger, goal number 6, clean water, number 13, climate action, and of course number 15, the life on land. If degraded soils are not restored, water scarcity already affecting 1 to 2 billion people, of which most live in drylands, may be aggravated by climate change and desertification. Because the rebellious dwell in drylands, for example Salem 68.6, Restoring desertified lands and conserving water in the root zone is like a cold water to a thirsty, weary soul. Furthermore, as Prophet Muhammad very rightly said, do not waste water even if you are at a running stream. Thank you for the opportunity to talk to you.